Hello, everyone. Welcome back to 360 on History. Please check out the website 360onhistory.com. Join us on all our social media, which are also on the website, and subscribe to our podcast and YouTube channel. Today, we are going to go back in time and talk about the story of our universe as it is told in two pictures taken by two different telescopes. Now, the story actually begins almost 14 billion years ago when our universe came into being. But we are going to take it up in 1948 when Ralph Alpherin, while doing research on the Big Bang, together with his colleagues Robert Herman and George Gamow, predicted the cosmic microwave background. Now, the Big Bang theory postulates that 12 to 14 billion years ago, our universe was only a few millimeters across. And from this hot, dense state, it expanded into the vast and much cooler cosmos we currently inhabit. The theory suggests that when the gases cooled, the universe was filled with radiation. That is literally the remnant heat left over from the Big Bang, called the cosmic microwave background, or CMB. So, that is actually what the cosmic microwave background is: leftover radiation from the birth of our universe. Now, we move forward to 1964 when Arno Penzias and Robert Wilson at the Bell Telephone Laboratory in Murray Hill, New Jersey, were building a radio receiver that they intended to use for radio astronomy and satellite communication experiments. However, something was acting as a source of excess noise in this receiver, and they just could not figure out what it was. At first, they thought it was the droppings of a pair of pigeons roosting on the antenna that was causing the disturbance, and so they had it extensively cleaned. This still did not get rid of the noise. Now, meanwhile, Robert Dick and other researchers at the nearby Princeton University were devising an experiment to find the CMB, or the cosmic microwave background. Having rejected all possible sources for the noise, Penzias contacted Robert Dick, who suggested that it might be the predicted background radiation. And it was. Both teams published papers in 1965, and Penzias and Wilson shared the 1978 Nobel Prize in Physics for their discovery. The CMB is invisible to humans because it is so cold, just 2.725 degrees above absolute zero, which is about negative 459.67 degrees Fahrenheit, or negative 273.15 degrees Celsius. So, as such, its radiation is much more visible in the microwave part of the electromagnetic spectrum. However, it fills the whole universe and can be found everywhere we look. Because it was emitted about 13.7 billion years ago, only a few 100,000 years after the Big Bang, and long before stars or galaxies ever existed, studying its properties in detail are helping us and have helped us to understand the conditions in the early universe. Which nicely brings us to the iconic image created out of 9 years of data collected by the Wilkinson Microwave Anisotropy Probe, or WMAP, which operated from 2001 to 2010. The WMAP's measurements played a key role in establishing the current standard model of cosmology. The image that it took reveals 13.77 billion year old temperature fluctuations, which are shown as color differences that correspond to the seeds that grew to become galaxies. It is helping cosmologists learn about the origin and structures of galaxies and also to measure the basic parameters of the Big Bang theory. And what we have learned is that the young universe, before there were stars, planets, or galaxies, was denser and much colder, filled with a plasma of ionized hydrogen. Expansion of the universe resulted in the plasma and radiation cooling down, and the protons and electrons combined to form hydrogen atoms. While before it was opaque, it now became transparent, and photons began to travel freely through space instead of being scattered by the earlier electrons and protons. The WMAP image takes us back to 380,000 years after the Big Bang. And then in 2013, the European Space Agency's Planck Space Telescope, which replaced the WMAP, perfected that picture and gave us the most detailed map ever created of the cosmic microwave background using over 15 months of data. The new image told us that the universe is not the same in all directions, and so much more. According to the European Space Agency, it shows tiny temperature fluctuations that correspond to regions of slightly different densities, representing the seeds of all future structure, the stars and galaxies of today. You can see both of these images on our blog on 360onhistory.com. Go and have a look at them. They are images of our universe when it was just a baby, and they are pretty awesome. Thank you for joining me on 360 on History, and I'll see you again next time.